Yeah, hi. Good morning. Okay, so hi. It's not morning. It's morning here, but it might not be morning there for you guys. All right. So what we did last class, the man was just trying to explain further more on regular sets, regular expression, and he started with revision on last class. Then he buttressed more points on this finite state automata. Automata also means machine. Yeah. So it was saying that there are two types of finite automata, which are the NFA and DFA. NFA means non-deterministic finite automata. Then DFA means deterministic finite automata. Now both of them forms the lexical analyzer. Lexical analyzer is also called the scanner. Anyways, all right. So now, what does these two things do? Both of them, they have just one more thing that they do, just one thing. They both NFA and DFA, they both are meant or they are used to recognize token. Token is also called regular set. That's the second name for token. Token is also called regular set. All right. So moving on, he gave us an example. He was trying to explain what he had taught us from the last class. He gave us an example of a regular set. Then he said we should find the members. So this is the example he gave us. So this is the example he gave us. He gave us 0 plus 10 asterisk. Then he said we should find the members. So if you want to write this plus means or. So in a more compiler way, that or can also change. You can write it like this: a standing slash, a standing slash. So that means this guy here you can write it as 0 or 10 asterisk. I hope you get that part. There is no magic. Plus means or also means that. So that means plus is also this, that is also or, like that. Those same way as when you're writing multiplication table, products in mathematics, when you say times is also dots, and is also can also be done as parentheses. So it's just something similar. So when you say plus, you can change it to this sign. So moving on, we said what are the members. Now we started with the members, which will be in a curly bracket. Now what this means is, in English term, it means 0 or 1 0 and occurrences of 0. Now occurrences of this 0 here, that's what that asterisk mean, occurrences of 0. Now occurrences of 0 can be, there can be a 0 and there might not be a 0. So what 0 asterisk means is there might be a 0, there might not be a 0, there might be just 1 0. The next one is there might be 2 zeros. The next one is there might be 3 zeros. Like that, you have zeros in infinity. So this is epsilon. Epsilon means not null or empty. Null or empty. All right. So that's what asterisk means. Whenever you have asterisk, let's say 1 asterisk, it also means 1 might not occur at all, or 1 occurs, it shows face, or another 2 1, or 3 1, or 1 2 3 4, or like till, except if they specially mention that 1 raised to power, let's say 5. That means you can have, it might not occur, it might occur once, it might occur twice, or 3 times, or 4 times, or 5 times, but it cannot occur 6 times or more. So these are the only set that can happen for 1 raised to power 5. All right. So let's continue. So based on this simple understanding of what 0 asterisk means, it means, so we'll use that to write out what the member set of this guy can be. All right. So we have the very first occurrences. We say 0 or 1 0 and occurrences of no, let me see, 1 and occurrences of 0. Yes, let's write like that: 0 or 1 and occurrences of, because this 1 and 0 are together, this 1 and 0 are together, so it is 1 and occurrences of 0. All right, so we have something like this. So that means 0, when you say 0 or, it means Toby or Tunde. So Toby or Tunde, it means that eba n pe Toby or Tunde wa. If somebody says that Toby or Tunde, that means Toby can come, or Tunde can show forth, or both of them can come together. Then I will now be done that, oh, since I call Toby or Tunde, it's fine, I can see anybody. But if I say Toby and Tunde, that means both of them must show face. Both of them must show face, not one. So in this case of or, it means that Toby alone can come, or Toby doesn't come, Tunde comes, or both of them comes, they show face. Whatever type of come you're having in your mind is your own thought. All right, so let's say this is Toby, 0, or this is Tunde. So for our first part, we can say that it's only Toby that came, so we have 0. That's the very first member of what this guy can produce, Now we continue. Let's now say that the next one is, now we said this one comes. Okay, let's say this one did not now come again. Let's say this is the part that is coming. Now if that other part will be coming, it simply means that 1, we said 1 and occurrences of 0. So remember we said occurrences of 0 starts from epsilon, which means nothing came, 1 0 came, 2 zeros comes, 3 zeros come, like that till you get to reach infinity. So now for the very first occurrence of 0, let's say no 0 came, so that means you have just 1, comma. That's another member of what this guy can produce. So let's continue. So let's say the next set is both of them, this one came and 1 also came, but the other occurrence of 0, nothing came, so that means you can have 0 1, comma. Another example anybody can guess now by now is that we can have, let's say 0 did not come at all, this one now came, and 2 occurrences of, or let's say 1 occurrence of 0 came, that means 1 0, or let's say 2 occurrences of 0 came, 1 0 0, or 3 occurrences of 0 came, 1 0 0, or both of them, both sides are coming, the first 0 came, which is from this side, and from this side 1 will definitely come, then occurrences of 0, maybe like 2 came, 0 0, like that. I hope we are following, or we are getting the magic. It's not magic anyways. All right, so that one is just an example, an honest example that the man was just trying to show us. So now when what he was so he also mentioned something, that the difference between NFA and DFA is that NFA, the difference, so the difference between NFA and DFA is that NFA is the superset of DFA, meaning that this is superset, meaning that what does that mean, sef? It means that all DFA are found inside NFA. They are inside NFA, but not all NFA are in DFA, meaning that NFA is like the baba of DFA. Now what is inside NFA that is not inside DFA, or what this simply means is that everything in DFA is inside NFA straight. Now what is in NFA that is not in DFA? So NFA contains epsilon, empty member. Meanwhile DFA doesn't. So that alone you'd have seen that, oh, now DFA, whatever thing that is in DFA is definitely inside NFA. Now DFA doesn't have epsilon, but NFA has it. So that's a difference there. All right, so let's also mention movement. There is something he also mentioned there. It is called delta. Now delta is written anyhow like this. Delta, it means a move or transition. It means a move or transition. Now when we say move or transition, let's say that okay, don't worry, before you even get to move or transition, let's also, so now to the main lecture, what he did last what's it called, in last last class. So he started with starting point. There's something called starting point and end point. Now we are now going more into the main lectures, which is around language, states and all. So we have something called the starting state. Now what is inside starting state? Starting state is represented with a circle, while final state is represented with two circles overlapping each other like that. So this is also called the starting state, and this is called the final state. We can have as many final states as we could have. An example of what we just showed you is this, when we have something like that, then we have something like this, then we have the final state to be 0 0. Yep, see, then we have that. So we can say that we have 1, which is the beginning, and 2, which is the ending. And let's say that we have something like this, meaning that, okay, we will explain everything later. Yeah, let's say we have something like this. Yeah, so what this means is that we'll be starting from 1, and our final state is 2. Now this final state means 2. So if you want to go from 1 to 2, you can either go, as you can see as the arrows are moving, so you can either go through this like that to 2. That means you can go through A to 2, or you can also go through B, because the arrow is here. That means you can also go through B to 2, but you cannot go through this other B. This is really B. So if you are coming back from 2 to 1, so what this diagram means that even from 2 you can also go back to 1 by going through B like that, because the arrow is pointing back to 1. So this one is really straightforward, like very 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 straightforward. So if you want to say that now this is, let's say the string is, for here we have 1 2, right? Now let's say that the string at the starting point is what? This is 1, and the string at the end, at the final state, is what? 2, because that's what we have here. Yeah, that's what we have there. So now let's talk about movement. Movement is denoted by delta, which means move or transition. Now when we see delta and we are moving from 1 and want to go through A, where would that lead us? So what this means from this diagram is that it simply means that if you are moving from 1 here and you are going through A, where does it lead us? It means that 1 and you are going through A, it leads us to 2. I hope we get that part. That's straightforward. So that means if you are going through 1 through A, it will definitely lead us to 2. So let's say if there is a movement and we have 2 and you want to go through B, where does it lead us? It means that you are coming from 2, our starting point is 2, and you are going through B, you want to follow B, Now this b is not where you are following, because the arrow is pointing to 2. No, this is the b that will be picking because the arrow is pointing back here, so it's leaving to going somewhere. So where does this b lead us? It leads us to 1. So you say the movement of 2 through b is 1. Are you following? Yeah, talking about movement, we can also have a movement table. A movement table looks something like this. When you have something like this, yeah, more like this. So what this simply means is that if you be moving from 1 and you want to pass a, where does it take us? From that diagram we have here. So if you are going from 1 and you want to pass a, where does it lead us? So obviously this one is saying that it will lead us to 2, so you write 2 there. So this is how you write the 2. You don't just write 2, just write a curly bracket and write 2. It leads us to 2. Now if you are going from 1 and you want to pass b, where does it lead us? This is 1 and you want to pass b, it leads us to 2 obviously, so you say 2. Now we are going from 2 now, I want to pass e, where does that lead us? 2 pass e, there is no e that goes back or anywhere, so we can't say that one is leading us anywhere, so you just say nowhere. And how do we represent nowhere? By writing an empty set. Now if you want to go, you are coming from 2, you want to pass through a to b, where does that lead us to? This is 2, then you pass through, it leads us to 1, so you just write 1. That's the movement table. Yeah, that's our movement table. All right, so let's take a more bigger example that is hot. Let me write it in red. A more bigger example. Oh, we're already running on 17 minutes. Yeah, we have a more bigger example here, which is this. Let me zoom in. Yeah, that's it. So 0 is our starting point. Then move on to 1 to 2, then 3 is our final state. Now from that our final state, we just have 1. Meanwhile, the final state can be more than 1. Yeah, it can be more than 1. This place too can be a final state, but it does have to be 00 like that. So if you see this, obviously you would have known that this is an NFA because it has epsilon. This is an NFA, it has epsilon. Yeah. So from here we can form our language set just like what we did here. Now also note that this guy can also be represented by using this diagram here. Yeah. So we can form our language set this way from what we have. Yeah. So let me just break down what we have here. So what are the language set that we could get or generate from this example that we are treating here now? So our very first thing to do, just like we've done before, is to have our L, which is the language set, open our curly brace, this. Then now the very first thing that we could generate from here is, anybody? Oh, sorry, I'm the only one here. Is let's say from 0 you can go to 1, which means a can be a very first thing. It can be the very first thing we have here. Yeah, a will just be sitting there predominantly, and you get what I'm trying to say. Yep. Yeah, obviously a can be the only thing here, and so no, cannot be the only thing obviously, because b is the only thing that enters the final state, so just be careful. So in fact, so that means since b is the only thing that can enter the final state here, it means that it can come. So let's see if b alone can be the only thing. So if you say b alone, so is it sure? So from 0 we go through epsilon, we enter 2. From 0 we go through epsilon, we enter 2. Now from 2 we go through b to enter 3. We go through b to enter 3. Is that not it? Yeah. So epsilon means nothing or empty. So that means the only language or string we have here is B. So that means B is valid. We can write just B. So let's cancel this. Let's see another thing that could go. So let's see. What if we don't go through epsilon? Let's go through this place. Go now. So that means we can have A. That means 0 passes through A to go to 1. Is that not it? 0 passes through A to go to 1. Then from there, from 1, it now passes through B to go to 2. It passes through B to reach 2. Now from 2, it passes through another B to reach 3. It passes through B to reach 3. That means we can have A, B, B. So we have A, B, B. Now if you note, B is definitely the last thing from everything, last thing. And the reason is because it is only B that enters the final state. So please note that you have to be careful, and you can't end it here as true. No, you must definitely enter the final state, except if this 2 is also a final state, like it has double circle like this, then you can end it at B. Or if 0 is the final state, you can also end it at 0 like that. But otherwise, for this case and this example, we must always enter 3. Always enter 3 before we say we are ending our English. All right. So what other language can we what other string can we get from here? So let's say from 0 again. I don't want to be marking again on. Okay, let me just keep marking. So we can go through. Let's go through epsilon again. Through epsilon we reach 2 abi. Epsilon we reach 2. Now through 2, we don't want to go 3. Let's say this and that one. Let's come back to, from 2, let's go back to 1 abi. Yeah, from 2, what do we go through to enter 1? That is this B up here. So we go through B to reach 1. Now from 1, we can either go this way or we go this way, because see the arrow here, it says that we can come here, and the arrow here says we can go there. So let's say, how do we go? Let's go back to 2. So what do we enter to get to? We go through B. So from 1, we go through B to enter 2. From 2, let's go to 3 direct. We go through B to enter 3. That's another finished one. So we have epsilon, B, B, B. I hope we get that, what I'm saying there. So I said we have epsilon, B, 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 which is epsilon, B, B, B. Yeah. So epsilon is obviously an empty set. So we'll be having just B, B, B. So we have B, B, B. So that's another string, B, B, B. Like that. You can have A, B, B, B. We can have A, B, A, B, B. Like that. But B shall definitely end it, because B is the only thing that enters A. So let's give a sample. So the man mentioned something that in the exam, he might ask something like let's say this. He might ask something like, is this guy a member of this set, or a member of the language on this what's it called, this diagram that we just draw? Or let's say you can say that, find, where's my English? Okay, you can say that, find let's say A, B, A, B, A, B, B. Can we find this guy in this expression here, in that expression? So he says that if you ask this type of question, if you just write yes, it is valid, that you only, if the mark is 3 marks, it will only give us half, not even up to 1. It will only give us half. That no, he doesn't want just yes is valid, even if it's valid, or he say no, it is invalid. That he doesn't want that. That is more, he expects us to explain in details what and how it is. So to explain in details, if this A, B is valid in this grammar, in that guy. So what we do is to write that, okay, is equals to Now we show it. How do we derive our A? How do we derive our B? How do we derive our A? So it means that to derive our, where is our starting point? Obviously this is our starting point, 0. So that means we will definitely start from 0. Now from 0, it then means that we'll move on from 0. We reach what's the name? A. Abi. We've gotten that A. Now if you go through it, what do you reach? Obviously not epsilon. This one is coming back here, so this is the A that we are going through, that we went there. So that means if you now go through this A, where do you go to? That's 1 Abi. So you write 1. We get to 1. So after you now leave 1, want to achieve this B here. So what do we do, or which of the B do we pass to get that B? Obviously from this one, the only B that we can pass is this B that goes to 2. So we say that we have B, and where does that B lead us? It leads us to 2. We are moving forward. Now we want to get what's it called? We want to get this A now. This A. So how do we get that A from what we have seen? And we are currently at 2. Now from 2, the only A that we can reach is this one is entering, this one is entering, this one is entering. So this is the only A that we can reach, and it went back to 0 because this is A here, and this is coming from 2. It went to 0. So you go through A, you reach 0. Now from that 0, from that new guy that we are now currently, we've achieved A, B, A, right? Now I want to get B, this B, which is next one. How do we get B? From 0, we can only go through A, or we go through epsilon. A and epsilon are not B, obviously, but epsilon mean nothing. So from here we can still go through that epsilon and reach a B, which is that. Do you see that? Or we reach epsilon and go through this B, or reach epsilon, yeah, either this B or this B, or this B here. So obviously we are going to go through epsilon. From 0, let us go through epsilon, and where does that lead us? We get to 2, right? Now from 2, we want to, so we've achieved this B now. Now we want to get another A. So from that 2, where do we, oh no, we want to achieve this B. We've not achieved the B. It's only epsilon that we got. We've not achieved this B yet. It's only epsilon that we got. So from epsilon, where do we go to get a B? We can go in 2 different ways. We can either come like this, or we go like this. So let's just go forward. The reason why we can go to the final state is because we can also come back from it. Assuming there is no this one here, assuming there is no this guy here, it means that we can't come back. That means it's just a one-way traffic. But since we can come back, so let's just go then part 3. So we'll get our B. We've achieved our B. And when we achieve our B, where do you go to? We went to 3. Assuming we went to this B, assuming we use this B and we went to, so that means we just say B and went to 1. But so I just show them that no, this is not the B we are using. That is the other B that we are using. So we just mention that we went to 3 from there, which is this 3. Alright, now from there we've achieved our B. Now we want to achieve A. Now from this 3, we are currently at 3. We want to achieve A. There is no A coming out, so but we have an epsilon. So from epsilon we enter 2 Abi. So let's say we enter 2 from epsilon. We enter 2 from epsilon. Yeah, from 3 we enter epsilon, then that gives us a 2. Alright, from 2 we are still trying to find our A. That's why we are moving parambolating like that. That's why we are parambolating. We are parabola. Alright, so from 2 we enter. How do we get our A? The only one A that goes to from 2 is from this place and went to, and it goes through to 0. So we say we have our A here. Then where does that lead us? It leads us to 0. Alright, fine. So from there, from that 0 again, we now want to reach, what's the name of this guy now? We want to get B. Now how do we get B? Let's say that we have the same way. Let's go through epsilon again from 0 to 2 so that we can achieve this B. So just say we go to this epsilon, and when we enter that epsilon, we went to 2. So we enter 2. From 2 we achieved our b, which is this b. It has gone. We are now inside 3. Now we need to get this last b, right? So and we are currently in 3. So how do we achieve that b? So from 3 we can just come back. From that 3 we can just enter epsilon, so that we can come back to 2. Then from that 2 we go through this b again to get our final state. So you all get that. So please, when you are at this second, because you want to get bb, don't go through b like this, because this other b will give you another b, but it will end in 2, which is not the final state, and that will be, so that's why we are going through b and entering b again. Yeah, so from our 3 we've gotten this b. Now we'll now need the last b. So from 3 we go through epsilon. So epsilon takes us to 2, and from 2 again we can hit our b to go through to enter 3. So that explains how we got a b a b a b b. So that means this guy is valid. Then you can now answer your question and say yes, comma, it is valid. So this is how we found it. We had our a b a b a b b. Yeah, so that's it. We are done with that. So remember we did something here where we are saying movement. So let's do our movement diagram here. Our movement diagram is something like that guy that we're trying to do. So let's say we have let's say delta, and what are the strings that we have here? We have a, we have b. What other letter? No other one, just a and b, right? So we just say we have a and b. Now what are the points, the states that we can reach? We have 0, we have 1, we have 2, we have 3, right? So we have, so just mention them: 0, we have 1, we have 2, we have 3. Now from what we just did or drew out here, just say that we have these guys. So from our diagram up there, so if we are going from 0, we've done this ahead earlier, yeah. So if we are going from 1, we enter 0. What does it do? Okay, that's what we want to do again. So if we are going from 0, that this is just if they say we should find the movement. So if we are going from 0 and we enter through a, where does it lead us? From 0 we enter a, where does it lead us? It leads us here at 1. So we just say that it leads us to 1. So if we are going from 0 and you enter through b, where does it lead us? 0 to b. There is no 0 to b, is epsilon, it's only a and epsilon, so you say that leads us to nowhere. So if you are going through a and you enter b, if you are coming from 1 and you enter b, a, where does that go to? This is 1 and you enter a, this is a, because it goes front and back. No, oh sorry, it doesn't go front and back. Oh yeah, it is just front only. Sorry, it's just front only. So so from 1, if you are saying that you are now going to, so a doesn't goes anywhere, so you just say it's empty. 1 through a doesn't go anywhere, there is no a connected. So if you are going from 1 and you want to pass b, this is 1, you want to pass b, it leads us to 2. Yupsy. Yeah, so I don't want that thing to be, it leads us to 2. So from 2 and you want to pass a, from 2 you want to go through a, okay, that leads us to 0. So you can write 0 or just leave it as empty, still back to Ibere, because it's our starting point. Please note, because it is our starting point, that's why you can write it as 0 or you can leave it blank like this. Okay, sorry. So yeah, this one is like this. Yeah, there is front and back arrow really. So you can either write 0 or leave it blank anyhow, because it's our starting point, that's why we can leave it blank, either 1 or 0. But I think the best thing is to mention there, so that we know that this one is an empty set, it doesn't lead us anywhere. But if it's leading us back to our very beginning, you can just mention. But whatever it is, just mention. I think best is let's do it this way so it will be explanatory and opened to everybody that it's 0 at a certain point or nothing. Alright, so from 2, you now want to pass through B. This is 2 and you want to pass through B. It can lead us to 3. It can also lead us back to 1. You see, this one is 2, so you write it can lead us to 1, comma, it can lead us to 3. Then close your bracket. So from 3 through 1. So I hope we get that part, because this what's it called, this guy 2 can lead us back to 1 and it can also lead us back to 3. So you can say 1 comma 3. So 3 and you want to pass A, nothing, and 3 and you want to pass B, nothing. So that one is like that. So this is the movement chart or the movement table. All right, I think we're done. Yeah, it just gave us more examples to explain blah blah blah. Like when you drew something like this, you do something like this, and he said this is the start, and you drew. Yeah, so he also mentioned something like this where we have this diagram starting from that, going through to that, and ending at 2. Yeah, so this simply means if you want to write this in the what's it called, lecture structure, you can write A or B, or A as many occurrences, then A, B. So let me draw this out again using this guy. So when you say A or B and many occurrences of either A or B, then A and B. So what that means is when you start from our point 0, so you are saying that either A or B can start, either A or B can start, then you can even have as many occurrences of A or B. That's what this asterisk means. So that means A can start, B can start. Then you can have this same A or B starting, then repeatedly. That's why we have this guy here curving like this. So A can come repeatedly, B too can come repeatedly. Then after these guys have come repeatedly, then you can now continue to A to our next step, then B, which is going to now be our final state. So that's how we got this drawing. I hope we get that. Yeah, I hope we got that. Thank you. I hope we got that.